Hello everyone, you are welcome to today's class. So in this class, we continue from where we stopped on LCM. But today we want to look at application of what we have learned. We've learned the concept already. Now we want to look at its application to real life. How do we apply the concept to real life? So when applying LCM to real life, there are two things you must take note of where we can apply. The first one is that LCM is applicable in the following cases. Number one is to analyze when two or more things will happen at the same time again. So two events. Let's say you have two events that happen at the same time now, but they are going to spend different durations, right? This one will spend one duration, this one will spend another duration. At what time will both of them start at the same time again? So that is what this one is. We are trying to analyze when will these two events occur at the same time. You understand? Or two things will happen again at the same time. So we use LCM to solve that problem, to find it if we have a large number. Exactly. So we'll look at example on that. And another one is another one is when we want to get something, multiple things, and we don't want the excess one to be more than the other. We also apply the concept of LCM to do that. Right. Now I will look at the first example first, which is this one. Example one for the first case. So a cinema runs its movies in two different halls 24/7 non-stop. So as this one finishes, it continues again, and so on and so forth. So one movie runs for 80 minutes. The first movie will run for 80 minutes, and the second one runs for what? 120 minutes. Now, both movies start at 2 p.m. Both of them starting at the same time. So, when will the movie begin at the same time again? When will they begin again at the same time? So that's what we want to test now. Now, before we apply the concept of LCM, let's try to solve it without, assuming we don't know that, we can use LCM to solve it. How can we solve this? So we have A, the first movie, then the second movie is B, right? Now, the first movie we spend 80 minutes, while this one will spend what? 120 minutes. Right. So immediately when this one finishes, so the next one will be what? You spend another 80 minutes. Right? Another one is what? This one will also say another what? 120 minutes. So when you add this together, you get what? 160 minutes. So when you add this one together, you get what? 240 minutes. So this one has appeared how many times? They have watched it twice. They have watched it how many times? Twice again. So you can see the number of minutes we are getting are not the same, right? This is 160, this is what? 240, right? So we want to assume whereby they are going to have the same number of what? Time. Are you with me? So let's add 80 to this one again. When you add 80 to this one again, you get what? 0, 4. That is 240. You can see this one is for 240, this one is for 240. So this one has appeared how many times? 1, 2, what? 3. So this one only was twice. But this one which means that the movie A will be watched 3 times, while movie B will be watched 2 times. The next time, the first time A will be watched, and the third time B will be watched, they will start at the same time, which is after what? 240 minutes. So 240 minutes here is what? That is divided by 60. When you divide this one by 60 minutes, 0 cancels 0. That is what? 4 hours. After 4 hours. So which means the two movies will start after 4 hours. So after 4 hours, when will that time be? And they started at 2 p.m. now. So adding 4 hours to 2 p.m. will be what? Which means they are going to start at the same time at what? 6 p.m. I hope this is clear. right? But in a situation whereby you can see we can solve it without LCM, but we can apply LCM because we want to see when they are going to be common again. So if we now apply the concept, instead of us doing all this, we just apply the concept of LCM. So which is LCM is what? LCM of what? 80 and 120. So we find the LCM of 80 and 120. 80 and 120, right? So let's use the structural method. 2, that is what? 40, 60. 2 can go 20, 30. 2 can still go, that is what? 10, 15, right? 2 can go 5, 15. 3 can go 5, 5. 5 can go 1, 1. So that means we have LCM here will be what? 2 times 2 times 2 times 2 times 3 times 5. So 2 times 2, this is 16. 16 multiplied by 15. This is 30. This is 8. This is 6. And this is 1. So this is 0 for 240. You can see we arrived at the same answer. So that is 240, and that is approximately 4 hours. So which is 4 hours. In the next 4 hours, both movies will start at the same what? At the same time. Is that clear? So which means they are going to start at by what? By 6 p.m. So that is how to apply the concept of what. So once you are able to okay, how will you know? Like something want to begin at the same time again, right? So you want to start something at the same time. Let's say for okay. So this is the second example. As you can see, it's very long, but the solution is very short. Very, very short. So you go out to a supermarket to buy sausages and buns for your friends. Unfortunately for you, sausages come in a pack of 6 and buns in a pack of 8. What is the least number of sausages and buns you need to buy in order to make sure you are not left with what? Surplus of either sausages or what? Buns. That is, you want to make sure that you buy equal number of sausage and equal number of what? Buns. Not that you buy these 8 buns, 5 you buy 7 sausage. Is that clear? So because they are packed differently, different numbers are in pack. So what I'm going to do is just LCM. So what is the least? What is the least? As you can see, the least, which is the minimum number that will make both of them to be common. To be what? Common. You can see they are still using common here, right? So in that case, so that means if we have 6, another 6, second pack, another 6, third pack. So this will give what? 24. You have 8. Sorry, this gives you 18. We have another 6. This gives you 24. You have 8 plus 8. This is 16 plus another 8. That gives you 24. So if you continue like that, the least, the minimum one, we continue. We are still going to get a point whereby they will be equal again. So if I do add 6 to this one, plus 6 plus 6 plus 6. 1, 2, 3, 4, 5, 6, 7. 6, that is 42, right? Plus another 6. Plus 6. 1, 2, 3, 4, 5, 6, 7, 8. That is what? 48. So plus 8 plus 8. 1, 2, 3, 4, 5. That is 40. Plus 8. That is 48. You can see. But we are looking for the least. So 1, 2, 3, 4, which gives what? 24. 1, 2, 3, also 24. The next one is 48. However, you can tell we are listing their multiples. We are listing their multiples, right? So that means we're going to make use of what? LCM. So we find the LCM of what? 6 and 8. Just find the LCM of what? 6 and 8. The LCM of 6 and 8. So LCM of 6 and 8 is what? 24. We use this one. 6, 8. Sorry, put it there. You can see 6 8, 2 can go 3, 4, 2 can go 3, 2, 2 can go 3, 1, 3, 1, 1. So 8 times 3, that gives us 24. So LCM is 24, right? So since LCM is 24, it means that the person, you are going to buy 24 pieces of what? Sausage and 24 pieces of what? Buns. Whereby you're not going to buy excess of one over the other. All this is very clear to you. So, as I always say, one thing about this kind of problem, because this is just like what problem, right? So it's for you to solve as many as possible questions. Once you're able to solve as many as possible questions, you'll be acquainted with the way questions comes in LCM that has to do with application to real life. So I hope this this video is useful and helpful for you. Kindly give us thumbs up and subscribe to our channel if you are new to this channel. If you're not new and you have not subscribed, you're missing a lot. Just try to subscribe and see the help you're going to get from that. So this is where we're going to stop today. So then we move on to the next topic on our scheme of work. So thank you for your attention and your time. So we'll see you in the next class. Bye for now.